All right. To finish off our discussion, we're going to talk about finding the angle of rotation of an object. And we have a regular hexagon here. It might not look that regular because my drawing capacity is maybe not the best, but I assure you it is a regular hexagon. Let me write that down. Regular hexagon. Okay. And we're going to rotate this clockwise about the center, which is here, clockwise. And clockwise is, of course, in this direction. Okay. So that the vertex L is moved to N. So we're going to move this vertex here all the way over to where this is. And our objective is how many degrees does the hexagon rotate? All right. Well, first, let's just imagine that we have a circle. This polygon is inscribed in a circle. And that this circle has a radius to each of these vertexes here. Radius means that all of these distances are the same. All right. Now, this is something that you should get used to doing a lot when it comes to geometry problems. You see here how we actually have 6 triangles inscribed in this circle now, and each of these lengths are the same. All right, because each of these are a radius of the circle as we defined it. All right, so each of these must be a what? Isosceles triangle at the very least. It turns out that they're actually more than isosceles, but we don't need that to prove this problem. All right. We can make a statement about what they are in just a moment, but let's consider this. We have a total of 1, 2, 3, 4, 5, 6 lines all connecting to the center vertex here, right? How many degrees is in the circle itself? Well, that's common knowledge. That's 360 degrees in a circle. All right. Now, how many times is the circle being cut up in the center here? How many angles actually do we have? Here, 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 and here, here, and here. Well, that's a total of 6 angles, right? And each of these angles are the same. So this is just 360 divided by 6. All right. So each of these angles is what? 60 degrees. Yes. All right. And just a quick mention, I said earlier these were isosceles triangles. Well, we actually just demonstrated that they're actually all equilateral triangles, because if this is 60 degrees and both of these lines are congruent to each other because they are a radius of the circle, well, then that means that this is also the same as this. And the only way that these two can be the same, because all triangles have a total of 180 degrees in them, then this must be 60 degrees. And this must also be 60 degrees, meaning that this is congruent to that. And by that same logic, all of these lines are congruent. Now, that's just a little bit of extra. All our real objective is here is to map from L to M and figure out what the total degree rotation for that is. Well, if you map once from L to M, that is a total of a 60 degree rotation. And if you map again from M to N, that's another 60 degrees. And the sum of 60 and 60 is 120 degrees. And so we find that if we map from L to N in a clockwise fashion, then we have rotated 120 degrees. All right? Notice, if we map from L to O, that would be a 180 degrees. If we mapped from L to J, that would be 240. If we mapped from L all the way to K in a clockwise manner, that would be 300 degrees. And just to prove that what we've done is correct, if we do a full rotation all the way around, well, that should be 360 degrees. And if we add another 60 degrees onto that, that is, in fact, 360 degrees. All right? So, one big takeaway from this. Always be looking for triangles. Triangles help a lot when it comes to solving geometry problems. All right. I hope you have a great and happy mathematical day. This is Mr. Bowen signing off.